For centuries, stargazing has fascinated humanity. Ground-based telescopes were among our earliest tools for peering into the night sky, and they have come a long way since their invention. These instruments have steadily improved our view of the stars, enabling us to capture far more light than our human eyes are capable of detecting. They've helped us map the heavens, identify planets, and unlock cosmic mysteries. But even the most powerful Earth-based telescopes pale in comparison to what the James Webb Space Telescope (JWST) has made possible. Designed as the next great observatory after Hubble, the James Webb represents a true leap forward in our quest to understand the universe. Unlike any telescope before it, the James Webb was engineered to peer deeper into space and further back in time than ever before. Its primary mission was to explore the origins of the universe, a lofty goal to be sure, but one that it is now fulfilling with remarkable success. One of its most headline-grabbing achievements so far has been the detailed observation of exoplanets, planets that exist outside our solar system. Among the most fascinating of these is Proxima b, which orbits our closest stellar neighbor, Proxima Centauri. Thanks to the Webb telescope, scientists have captured what has been described as a visual hint of artificial illumination on that planet, a phenomenon some have dubbed a city of lights. Whether or not that's truly what we're seeing, it's a profound milestone that opens new questions about life beyond Earth. The Webb's power doesn't stop there. Scientists are currently working to collect 18 separate images, one for each of the telescope's individual mirror segments, to fine-tune its optics. This meticulous process ensures the telescope provides the sharpest images possible. Even in its early stages, the telescope stunned the world by capturing one of the clearest images of an exoplanet ever taken. It's more than a pretty picture. It's a doorway to understanding alien worlds in greater detail than we ever imagined. Perhaps the most astonishing capability of the James Webb is its ability to look back through time. Literally, light from the earliest galaxies has been traveling through space for billions of years, and this telescope can now detect it. Scientists estimate that Webb can observe galaxies as they existed when the universe was only 200 million years old, a time when the first stars and galaxies were just beginning to form. This period is known as the cosmic dawn. By studying it, we gain a clearer view of how everything began, how galaxies evolved, how stars formed, and perhaps even how life as we know it came to be. The telescope's extraordinary vision is made possible by its massive 21-foot mirror, which captures faint light from the most distant objects in the universe and reflects it into its scientific instruments. The James Webb is equipped with 4 powerful instruments, each designed to explore different aspects of space. First, there's the near-infrared camera, NIRCam, which is the primary imaging tool and takes detailed pictures of distant galaxies, nebulae, and other cosmic phenomena. Then there's the near-infrared spectrograph, NIR-SPEC, which breaks light down into its individual wavelengths to reveal the chemical makeup of stars and planets. There's also the mid-infrared instrument, MIRI, which is specifically tuned to detect cooler objects like distant exoplanets and faint galaxies. Finally, a fine guidance sensor paired with another spectrograph ensures precise pointing and captures even the most delicate infrared signals. You may wonder why infrared light is so important. Unlike visible light, infrared can pass through dense clouds of dust and gas that often obscure celestial objects. This makes it the perfect tool for studying the birth of stars and the composition of distant worlds. Infrared is also ideal for examining cool objects that don't emit much visible light, such as the atmospheres of exoplanets or ancient galaxies shrouded in cosmic dust. By tuning into this often overlooked part of the spectrum, Webb is uncovering features of the universe that would otherwise remain invisible. One of the telescope's most exciting achievements was the direct imaging of an exoplanet known as AHP 65426b. Discovered in 2017, This gas giant is about 12 times the size of Jupiter and lies at a distance from its star nearly 100 times farther than Earth's orbit. Scientists used multiple filters on the Webb to gather images of this distant world, which were then combined to produce a clear, direct view. This is an enormous achievement for astronomy. Capturing such a detailed image helps us learn more about how exoplanets form and evolve. It also offers insights into their atmospheres, climate conditions, and even potential for life. Although these early findings haven't confirmed the existence of a habitable planet, they prove that if one is out there, the James Webb Space Telescope is the tool that will find it. It gives us the power to zoom in on planets light years away and analyze them in ways that were previously only dreamed of. And if there is a planet out there with the right conditions to support life, maybe even intelligent life, we're now more likely than ever to detect it. And then came perhaps Webb's most breathtaking discovery yet: the oldest known galaxies ever observed by humans. These galaxies were formed just 300 million years after the Big Bang, when the universe was a mere 2% of its current age. Light from these galaxies has been traveling through space for 13.4 billion years before finally reaching us. Imagine that we're seeing light that left its source before the Earth even existed. To locate and study these galaxies, scientists used Webb's infrared sensors to detect their faint glow and analyze the redshift, a way to measure how much the universe has expanded since the light was emitted. The results confirmed that these are the most distant and ancient galaxies we've ever seen. This discovery has huge implications. These early galaxies tell the story of how the universe first organized itself into stars and clusters, the building blocks of everything we know. Studying them allows us to fill in gaps in our understanding of cosmic history. What makes this all the more impressive is that the telescope was able to gather this information so quickly after becoming operational. In another fascinating development, scientists have begun to explore whether Webb can detect artificial lights on distant planets. Take Proxima b, for example, a rocky world located just over 4 light-years away, orbiting the red dwarf Proxima Centauri. It lies in the star's habitable zone and is likely tidally locked, meaning one side always faces the star while the other remains in permanent darkness. If an advanced civilization lived there and used technology similar to ours, like solar panels or electric lighting, those city lights might be detectable. According to recent research, the Webb could potentially pick up artificial illumination on the night side of the planet, even if it's as faint as our own city lights seen from space. And with future telescopes planned by NASA, this ability will only get stronger. The idea that we could one day detect the glow of a civilization 4 light-years away is truly mind-blowing. It reminds us how much we've already discovered and how much more there is to learn. The James Webb Space Telescope isn't just a new piece of equipment. It's a window into our past, our future, and the possibility of other worlds like ours. Whether it's finding signs of life, studying the first stars, or revealing hidden galaxies, Webb is transforming everything we thought we knew about the universe. So, as we look to the stars, we're reminded that age doesn't dim our curiosity. It deepens it. With every new image and discovery, the James Webb Space Telescope invites us to wonder, reflect, and dream once again. Maybe the biggest discoveries of all are still waiting just beyond the next star.